Okay, good morning, everybody. So today we are going to start into day 2 of chapter 1, section 4. And what I'm showing you today is how to complete the square. Now, this for almost all of you is going to be a completely new technique that you have not learned before. So I'm just giving you the heads up that this can be a little tricky until you kind of catch on to it. So this is brand new. So just wanted to let you know that because this is not anything that you've learned before. So completing the square is a technique that we use to factor quadratic equations that otherwise would not be factorable. So as an example, if I were to look at this x squared plus 2x minus 6, and I said, okay, I need two numbers that multiply to give me negative 6, but they add to be positive 2. So the numbers that would give me negative 6 would be 1 and 6, or 2 and 3. One of them would have to be negative, and one would have to be positive. And if you go through the different options here, negative 1 and positive 6, that would be 5. Positive 1 and negative 6, that'd be negative 5. Or negative 2 and positive 3, which would be 1, or 2 and negative 3, that would be negative 1. None of those are going to work. Okay, so this particular equation, as it sits, is not factorable. Now, that doesn't mean it's not solvable, in which we'll talk about the quadratic formula, which we could use to solve this, and that always works. But there is another way, and that way is called completing the square. And completing the square is an alternative to the quadratic formula in that it also allows you to solve all quadratic equations, which I'll kind of go into in a little bit here. But the idea here is that you are going to rewrite the equation into a new equation that is factorable. Now, there's a technique to it, and that technique that you have to remember, or the part of this that you need to remember, is this part right here where you have b over 2, the quantity squared. Okay, so we need to keep that in mind. I'm going to show you where that comes into play here in a second. So the first thing that we need to verify is that this lead coefficient in front of the x squared is 1. If this is not 1, you have some other legwork to do before we can complete the square. And as we progress through this, I'll show you some examples where that's the case. But for now, you can see our lead coefficient is 1, so we are good. We can proceed to complete the square. So the first thing that you're going to do is that you're going to group the x terms together, and you're going to leave the constant term out by itself, just like you see me grouping. And now we need to use this little formula right up here where I said, oh, remember this, b over 2, the quantity squared. So if I were to line this up, ax squared plus bx plus c, you can see that b is 2. Okay, so that's the number that we're going to use in this formula, b over 2, the quantity squared. Now I'm going to do that off to the side. So b over 2, the quantity squared, is going to be 2 over 2, the quantity squared. Now I don't want you to skip any steps in here. So that's going to be 1 squared, which is 1, and you'll see why here in a second. So as I do this b over 2, the quantity squared, I get 2 over 2, which turns into 1, and 1 squared is 1. This new 1 that we have right here, we are going to use to rewrite our equation. We're going to expand the equation. So I'm going to leave the x squared plus 2x there, but I'm going to include a positive 1. That positive 1 comes from what we got using the formula b over 2, the quantity squared. Now we still have the minus 6, but if you remember anything about equations, if you add a number to one side of the equation, unless you add the number to the other side or compensate it somehow on the same side, you change the equation. We can't change the equation. We've got to keep the equation the same. So because we put this plus 1 on the inside right here, we are going to put a minus 1 on the outside. Okay, now let's take a look at what we're doing. And again, this problem is going to take longer because I'm showing you step by step. But what you need to see is here, this positive one and this negative one, the net sum of those is 0. They would go away. They would eliminate each other, and we would be just left with -6. And that's the point, because we started with a -6. We can't add something without taking away on the same side unless we want to change the equation, which is not what we want to do. Okay, so we added one on the inside and we subtracted one on the outside. Okay, now we need to clean this up, but we're also going to factor this. And this is the great thing now. This right here is a new quadratic equation that is factorable. Okay, we created something that is factorable. The old one was not. This one is. So if you want to think about how to factor it, you can do that. Or you can simply look at what the number is up here, and that will tell you exactly what number goes in the next part. So we have becomes x, and then in this case, this was a +1. So we write +1, and then it's the quantity squared. And then right here, you can see we have -6 minus 1, which becomes -7. And then the whole thing equals 0. Okay, now again, what I underlined right here, if you want to think about how to factor that, you can, and what you'll realize is that factors into x plus 1 times x plus 1. But that can be rewritten as x plus 1, the quantity squared. The main thing that I want you to understand is where these come from. This one that we got when we did b over 1, this one right here that we got, gets inserted right there. Okay? And then this one that we got before we squared it gets inserted down there. Okay, and that's going to hold true for all of these completing the square problems. And now from here, we have something that we can solve, right? So now that it's rewritten as x plus 1, the quantity squared, minus 7 equals 0, I can simply take this thing and add 7 to both sides. And I'll be left with x plus 1, the quantity squared, equals 7. I can then take the square root, which gives me x plus 1 equals the plus or minus square root of 7. And lastly, I can subtract 1 from both sides, and I get x equals -1 plus or minus root 7. And these two would be the solution to the original equation that we started with. Now, I know that seemed like it was a lot because it kind of was. I had to go through and explain a lot. Sorry about my lights. It likes to keep going out when I'm sitting at my desk. But let's try another one, okay? So here's another one. We have x squared minus 4x minus 1 equals 0. The first thing that we're going to do is we're going to verify that this lead coefficient right here is 1. It is, so that's good. So then we're going to group these two terms together. We're going to take the b that's on the inside there, okay? And that b is a 4. So I'm going to do the b over 2, the quantity squared, which is -4 over 2, the quantity squared, which is -2 squared, which gives me 4. Okay, so that's the first number we're looking for that 4. We are going to use that 4 to rewrite this equation. And I don't want you guys to really pay much attention to this, okay? We're going to use that 4 to rewrite the equation. That 4 is going to go inside the set of parentheses we just wrote. So we're going to have x squared minus 4x plus 4. It's plus 4 because this was a positive 4. Okay. And then we're going to close out parentheses. We still have the -1 and we still have the 0. So you can see right here, I put that positive 4 in. Okay. Now we're going to factor. What we've created right here, and I actually, hold on. I forgot to. Remember, if I put a +4 here, I got to do a -4 on the outside. And I just about made the mistake that I see the most often from students, which is if you put the +4 on the inside, you got to put the -4 on the outside. Students forget to do that all the time, and I actually almost forgot to do that. So don't do that because you'll get a completely wrong answer. Okay, so the next thing is we have created a new quadratic equation. that is indeed factorable, the way that it's going to factor is always the same. There's always going to be an x and there's always going to be a square. This number that we get right here comes from this number. It's the number before we square it. So in this case, that's a -2, so I'm going to write a -2 right there. Now this -1 minus 4 turns into -5, and then we have 0. And we're done. We've completed the square. From there, we just solve it by moving the 5 to the other side, square rooting both sides. Don't forget about your plus or minus. And then we're going to add 2 to both sides. And that can't combine with the 5, so we just end up with 2 plus or minus root 5, just like that. And there are our 2 solutions. Now, here's another example of this. Now, this one's going to be a little bit harder, which you'll see why here in a second. But I don't want you to really look at any of this again. Okay, I'm not going to teach you guys quite that way. It's a little bit different. And there's a reason why, which I'll go into later. But so we have this equation right here. You can see that we would need 2 numbers that multiply to give me 3 and add to be 5. There are not 2 numbers that will do that. The only factors of 3 are 1 and 3. And 1 and 3 is equal to 4. So this is not factorable using our normal techniques that you already know how to do. So we need to factor this by completing the square. So the first thing to do is to, again, verify that the lead coefficient is 1. It is. So we can proceed to the next step, which is to group the 2 x terms together and then identify what b is. B is 5 in this case. So we need to do the b. I'm going to write this in black right here. B over 2 the quantity squared, which is 5 over 2 the quantity squared, which is 25 over 4. Now I think you're seeing why this one's a little bit harder. The b was not even, therefore it was not divisible by 2, which gave us a fraction. And we know how much people like fractions. They don't. So this one's going to be a little bit trickier because of the fraction. But nonetheless, the 25/4 is the number that we need to create the new equation. So that new equation is going to be x squared plus 5x plus 25/4. That's what's all in the parentheses. We still have the plus 3. We need to subtract the 25/4, and then that's all equal to 0. Okay? All right, so now this is why I showed you before what I did on how this part right here ends up factoring. There's an important part of this that you need to make sure that you understand, which comes up here. If you look at, in this particular problem, this -2 that we had right here, where I'm putting the highlighted arrow, that -2 gets put right down there whenever we factor, okay? And so that's the number you get before you square it, okay? So going down here, the number that we got before we square it is right here. So this equation is going to factor into x and then plus 5 over 2. Let me get the 2 better. The quantity squared. And then we have the 3 minus 25/4. Now, I do need to clean that up. I'm going to do that off to the side. 3 over 1 minus 25 over 4. The 3 over 1 gets multiplied by 4 over 4, so I get 12 over 4 minus 25 over 4, and that gives me negative 13 over 4. So this becomes negative 13 over 4. Like that. Okay, now from there we can proceed to solve by isolating the x variable. So the first thing we're going to do is add 13/4 to both sides, and we get x plus 5 over 2 squared equals 13/4. We're going to square root both sides. When I do that, I get x plus 5 over 2 equals the positive or negative square root of 13 over 2. Remember, the bottom and the top get square rooted, and the square root of 4 is 2, which is nice because then we don't have to rationalize that because you're not allowed to leave a square root in the denominator. The last thing is you're going to subtract 5 halves from both sides, and you're going to get x equals negative 5 over 2 plus or minus the square root of 13 over 2. Now, if you really wanted to, you could write this final answer as one fraction because they do have the same denominator. So you could write it like this. I'm not going to mark one right and one wrong. Either one is fine. So like I said, that one was a little bit harder just because of the fractions. It made it a little bit of a nastier problem. So that was part C. Here's one more that I'm going to show you. So this one again, we want to solve this by completing the square. And so the first thing you can notice, this is not in standard form, or as the book says, general form. So we do need to get rid of the 7x, and we need to get rid of the 4 on both sides, so we get a quadratic equation in standard form like this. So you can see I have x squared minus 7x minus 4 equals 0. Now again, if you tried to factor this on its own, you would need two numbers that multiply to give you negative 4 and that would add to give you negative 7. There are not two numbers that will do that. So we are limited on the technique that we can use. You should try more basic factoring techniques before you complete the square. This is definitely for problems that won't factor using more traditional methods. So the first thing we're going to do, we are going to verify that the lead coefficient is 1, and it is, so that's good. So we can proceed. And so I'm going to take and I'm going to group the x terms together. I'm going to get my b out of there, which is negative 7. I'm going to do the formula b over 2, the quantity squared, which is negative 7 over 2, the quantity squared, which is 49/4. Okay, so that's the number we're going to use. Now remember, and I want to reiterate this, do not skip any steps when you're calculating b over 2, because you need those steps to know how stuff's going to factor. Okay, so now this 49/4 is going to get added into the parentheses there. So I'm going to write x squared minus 7x and then plus 49/4. We're going to close our parentheses. We still have the minus 4 there. We also have to subtract 49/4 on the outside because remember, the sum of this and this need to be 0. They need to cancel each other out, so we keep the equation the same. So now we have completed the square. We need to factor this part. The nice thing about this technique is in order to factor that, you simply look at the number that you got before you squared. And that's the negative 7 over 2. So what we end up with is this turns into x. It's always going to be parentheses and an x. And then it's going to be this number right here. So it's minus 7 over 2. And it's the quantity squared. Now we need to simplify this minus 4 minus 49/4. So I'm going to do that off to the side. So I have negative 4 minus 49/4. So I need to make the negative 4 over 1. I need to multiply it by 4 on the top and the bottom. So I get negative 16 over 4 minus 49 over 4. Now negative 16 minus 49 is going to be negative 65 over 4. So that's what this turns into. Equals 0. Now from there to solve, I'm going to move the 65/4 to the other side. And then I'm going to square root that. And lastly, I'm going to add 7 halves to both sides. And because the denominators are the same, we can combine the fractions into 1. That's typically how I'll do it, but I won't mark it wrong if you did it like in the last problem and you left them as 2 separate fractions. That's okay too. So, all right, guys, there you go. There are quite a few examples of how to complete the square. Hopefully that made sense. This is definitely tricky. I know that. If you're struggling, please let me know. Please make sure you're asking questions during our live meets. So if you need me to clarify anything, I'm able to do that for you. So have a great day.